Hello and welcome to help session here. Physics, Unit 2, Lesson 4. I had a question about number 66. Two rugby players are running towards each other. They are 37 meters apart, so one accelerates. So we've got two players here, so we need to separate the information. So if I give myself a quick sketch here, so I'm going to call this one person A. I'm going to give this one person B, my very accurate stick diagrams. They are 37 meters apart. They go and run toward each other, so they're heading toward each other. So I'm going to go with person A information. One is accelerating from rest. So person A, their initial velocity is 0 meters per second. They accelerate. So they have acceleration. They have non-uniform motion, 0.5 meters per second squared. The other person, so they jump to the other person on me here. So already moving, so the velocity is constant based on the information provided. 3.1 meters per second, and then maintains their speed. How long before they crunch together? So we got to find impact. Impact is going to happen somewhere in between person A and person B. We don't know. So if I say that person A, to get to impact, travels X meters, that would mean that person B traveled 37 minus X. So now I have additional information here to add to my stack here. So we know that delta D for person A is X, and I know delta D for person B is 37 minus X. Time is the only thing that is constant between the two. All right, so time is the only item that's transferable in this case across the two situations, and I guess in this case also X is on both sides. So let's take a look at what information we have. So let's start with person B. It's non-uniform, so they're usually the easier equation. So delta D equals VT. So 37 minus X equals 3.1 is the velocity times time. All right. Two unknowns. Okay, so I'm kind of stuck. I have one equation, two unknowns. So let's look at what happens with person A. So when I look at person A, d v1 A and t, so I'm going to use delta D equals v1t plus 1/2 at squared, because that's what information works here. v1 is 0, so that term will go to 0. So delta D is x equals 1/2. Acceleration is 0.5 t squared. And simplifying that down, so we get 0.25 t squared. And again, I'm kind of stuck because I have one equation, two unknowns. But now I have information that is information that's transferable across the two situations here. So, oops, shrink that down so I have a bit of room. What I can do now is I can say, well, let's put equation number 2 into equation number 1, which means that 37 minus, instead of x, I'm going to replace it with 0.25 t squared equals 3.1 t. Moving everything to the same side, positive 0.25 t squared plus 3.1 t minus 37. So now you have a quadratic equation. So you're going back to grade 10 here. You need to use the quadratic formula to solve. So I'm going to pull out a 0.25 so I don't have decimals in my answer. So t squared plus, it's like multiplying that by 4, so 12.4 t minus 37 times 4. You don't really need to do this. You can go right into the formula. 148. So our formula, t equals, if you forget it, negative b plus or minus b squared minus 4ac all over 2a. So negative 12.4 plus or minus 12.4 squared minus 4 times 1 times negative 148 all over 2 times 1. Means I get negative 12.4 plus or minus, so inside there 12.4 squared minus 4 times the 1 times negative 148. I'm going to square root that. So I get 27.3 over 2. So I'm going to get two possible answers here. So I get negative 12.4 plus the 27.3, divide that by 2. So let's call that 7.5 seconds. Or negative 12.4 minus the 27.3, divide that by 2, and I get negative, let's call it negative 20 seconds. Can't have a negative time, so this is inadmissible in this situation. Inadmissible. So therefore, they will collide. They will collide after 7.5 seconds. Now, what was the question asking? I don't even remember anymore. A, how long? So we did get A, so I just answered number A, or letter A, English people. How fast was the accelerating player going? So how fast was the player going at impact? So B, we want to know V2. All right, we know V1, we know AT, so V2 equals V1 plus AT, 0 plus 0.5 times 7.5. So plugging that in, 7.5 times 0.5, not sure I used a calculator on that, 3.75 meters per second. All right, so almost a little bit faster, so they almost hit at the same velocity. C part, how far did each player run? So we need to find X. All right, you can pick any of the formulas now. If you look back up here, we can really, I hate squeezing, I won't squeeze it in. So I'm gonna copy, I'm gonna take it down here, extend my page bit. Nope, didn't want to do that. Paste. Okay, so magic of technology. So part C, 37 minus X equals 3.1 times the 7.5. So I'm just using one of the two equations from above. So 37 minus X equals 7.5 times 3.1, 23.25. Manipulating that around, we get, oops, not 35, 37, 13.75 meters. So therefore, they collide 13.75 meters right of person A for my diagram. All right. So the tricky part for this question is setup. All right, is getting that 37 minus X and X. This will be the part that kind of unlocks the whole question right there. Once you get that set up, it is possible. We do run into using quadratic formula in the physics course, more so in the grade 12 course, but a little bit in grade 11. So if you have any other questions or any clarification, let me know, and I will see what I can do for you. Good luck.